Okay, right here. So the next thing that we're going to be looking at is it says find all the zeros, which is a synonym for solutions of this particular polynomial. So we've already done one like this. Before we use the x, we have to make it look like a quadratic, so we're going to factor out, right? Factor out the x, and then we're going to use the x to figure out what the solutions are. But what if the x doesn't work? What if I can't use the x, man? What if I can't, the x, there's no factors of 1 that would give me -1. So how am I supposed to find the solutions? Well, we've got 5 different ways that we can solve a quadratic, so let's just use that other one, right? We have the quadratic formula, okay? So quadratic formula for the second half, which is going to kind of suck, and when we do that for the quadratic formula, we get something like this. So we still have that x equals 0, that's up there, and then we also have that. So that would be the solution for that ugliness. Okay? Why don't you guys see if you can try to do this? Look, I know what you're thinking. Wait, Mr. Wilson, that one was a lot easier than this one. Yeah, well, of course it was. This one has 4 different terms. This one only had 3. So even if you pulled out something, like let's say if we were to factor by grouping, I don't think we're not going to even be able to factor by grouping because you're going to have a 7 and over here this is going to be a 1, okay, when you pull out an 18. So there's another method that we can use in order to figure out what the solutions are. So remember, factors are really important, okay? And one of the ways that we can find factors, like let's say if I have 63 and I want to know what a factor of 63 is. Well, I could just say, you know what, I want to divide this by 9. Okay, when I divide 63 by 9, I find out what the other factor was, right? So I know that 9 and 7, those are both factors. So how do we do this for this kind of a thing, right? Right here. How do I take a polynomial that has 4 terms and understand what's going on? Because look, do you guys see how on this side, it actually gives us one of the zeros. It says that this is a solution, okay? So we're going to use this technique that I don't know if your Algebra 2 teachers taught you, but it's called synthetic division. Okay, so we're going to take this factor, or this solution, and since this is a factor like this, where that's going to be x plus 3, okay, I already know that one of my factors is this. I'm going to divide this into here to see what another possible factor could be. So watch what I do. I have to keep the -3 whenever I'm using synthetic division here. Let's look at what that says. Okay, so synthetic division, I put the -3 on the outside, and then where did I get this 1, this 7, this 18, and that 18? Anybody know where I got those numbers from? Oh yeah, they're the coefficients, right, to this polynomial up here. So how we do synthetic division is like this. The first one always gets a free pass, okay? So the 1 comes down. Then the -3, you have to multiply the 1 times the -3. -3 times 1 is going to be -3. Then we just combine. So 7 minus 3 gives me 4. Now what's the number that should go right here? Tell your partner. -3 times 4, that'll give me -12, right? Then we combine, we get 6. -3 times 6 gives us -18. So this is how it works. Watch this. Whenever you get a 0, that means that it goes in evenly. And we already knew that. And we knew that it was a factor, okay? And how I always remember this is, since this goes away, then that means that this is your constant, this is your x term, this is your x squared term. Okay, and then if you had more terms, then it would be like this, x cubed, and then x to the 4th, then x to the 5th. That's how synthetic division works. Okay, that's after your remainder is so this is always your remainder right here. Okay, so I know that one of my factors, looking over here, is x plus 3. Okay, so this one is 1, that one's 4, that one's the constant term, okay? And then I also have x plus 3. This is in factored form. Now to find out what the solutions are, well, we take the opposite of this one to get x minus 3, right? And then how do I find the solutions for here? Are there factors of 6 that would give me 4? Yeah, no, so then we're going to just have to use the quadratic formula. Okay? So just trust me that when I use the quadratic formula, I end up with this ugly thing right here. Okay, those are the solutions. Notice that we have 3 solutions. Okay, so I have a solution here, and there's 2 solutions here. See, whenever there's a plus or minus, that means you have to add it, and then you have to subtract it. So I've got 3 possible solutions. Notice that I'm also looking at the degree to see how many possible solutions that I can have. Okay, up here, this one has a 3, and we have 1, 2, and 3 possible solutions. Okay? All right. What about this ugliness? So we have a degree of 4, and it looks like this, and then it tells us that we've got this solution and we've got this solution. Okay? So we're going to use this synthetic division like we did a while ago, and we're just gonna hash this thing out and see what we get. Okay? So first step, we've got the two factors already as x plus 1, x plus 1. Okay? I already know that. Okay? Now I'm going to use synthetic division. I'm going to put the negative 1 in the little box, and then I'm going to say 1, and then the negative 1. Wait, how come? Where did I get the 0 from? Turn to your partner real quick and say, hey man, how'd you get this 0 up there? Yeah, whenever we're doing synthetic division, if we're missing a term in the sequence, like we don't have a cube term. Since we don't have a cube term, we put a 0 placeholder in that position. Okay? So remember, the first one gets a free pass. Then the second one, we have to multiply this times this to get the negative 1. Then we have to simplify. That becomes negative 1. Why don't you guys see if you can finish up the rest of this synthetic division. Alright, so multiply negative times the negative. That gives me a positive 1. That's going to give me 0. This times 0 is going to be 0. Then bring down the 2. That gives me a negative. Okay. So this 0 right here, remember, that's my remainder. That's my constant. That's my x. That's my x squared. This is my x cubed. Okay? So x plus 1, we know that one is already there, right? And then now we have x cubed, x squared. We don't have an x term. My constant is 2. Got me? Alright, so my solutions are negative 1, but then how do I figure out what the solutions are of this? Well, since we still have a cube, we're not there yet. We have to try to strive to get this to look like a quadratic. So that just means that we need to divide it again using synthetic division. Remember how we have a negative 1 and we already have, okay. So we've still got an x plus 1, right? There's 2 of these. So let's still use synthetic division, but put negative 1 in here, and we're just going to do it for this portion of the factored form right here, okay? So that's the 1, that's the negative 1, there's a 0 placeholder, and that's the 2. So why don't you try doing synthetic division there? Alright, so the 1 gets the free pass. This times this gives me negative 1, that'll be negative 2. This times this will give me positive 2, 2, multiply, you get negative 2. Okay, so now that's a remainder, that's my constant, that's my x squared. Okay, so now I have a quadratic. And remember, we have an x plus 1, and we have another x plus 1 also. So this is what this thing looks like in factored form. So to find out what the solutions are, we take the opposite of this. That's going to be negative 1. Opposite of that is negative 1. Still the same thing. Now, are there factors of 2 that would give me negative 2? Nope. So what do you think we're going to have to use? Yep, quadratic formula. So if we do the quadratic formula for that, we're going to end up with something like this. Nice job. Just when you thought all the complexity was all done, there's one more thing that I really need to hit, and then we can take it from there. So here's the deal. If I were to say that the solutions were x equaled 2 and negative 3, you'd be able to tell me what the actual polynomial looks like, because you just go backwards. You'd say, well, if I got a solution of 2, that means that the factor looked like this, right? And then if I got a solution of negative 3, that means that the factor looked like this. And then all you would have to do is just multiply. So that's x squared, that's positive 3x, that's negative 2x, and then that's negative 6. And then you could actually figure out what the polynomial looked like if you have the solutions. Do you guys see that? So that's where we're going now. I'm going to show you the solutions, and then you're going to be able to figure out what the polynomial was. So, like, what happens if you have something that's complex, though? 2i. Okay? Like, if I told you that x equaled 2i, what the heck? Okay, well, how do we get imaginary numbers? We only get imaginary numbers whenever we take the square root. And then whenever we're solving, and we take the square root, that means that there used to be something that was squared. So that means that there's going to be plus or minus. So whenever you have 2i as a solution, then negative 2i will also be a solution. Do you guys see how these two numbers, these are called conjugates? Okay? So if you know that 2i is a solution, or it tells you, then that also means that this is a solution. Now how do I write that as a factor? Well, it's just going to be x minus 2i. That's what this one will look like. And then this one is going to be x plus 2i. Okay, so we would just distribute, and then we can figure out what what the polynomial would look like. So let's try this one, and then I think I'm done. Alright, so first off, it says it's a degree of 3. So I know that it's going to be like x cubed, blah, 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 right? It says that the solutions, or the zeros, are x equals 2, and then the other one is going to be 3 minus I. Now, if 3 minus I, since this is complex, is a solution, I also know that 3 plus I is going to be a solution as well, right? Because these are both conjugates. Alright, so the first one's going to be x minus 2. And then these two guys, I'm going to do these over on the side, okay? Because I'm going to multiply these first. I have 3, hold on. I have x minus, watch this, 3 minus I. And then I have times x plus 3 plus I. Okay, so look, this looks confusing. I'll simplify it in a minute. Don't complain and cry. Okay, so see, I'm taking this, and one's negative, and one's positive, right? So I'm taking the same deal. Okay. Oh, excuse me. Hold on. I have to take this. Has to be minus. Here, let me just erase it. And why don't I just erase half this thing? Okay, minus. All right. So I'm taking the opposite of these two things. So there's both minus sign right there. Now let's simplify. I have x, and then distribute. That's going to be minus 3, and then that's going to be plus I. That's what this first thing is. Then in here, this is going to be x minus 3, and then that's going to be minus I. So to simplify it, you're not going to like it, but just get over it. X times x is going to be x squared. X times negative 3 is negative 3x. X times negative I is going to be negative xi. That's the first one. Okay, now the second one, I'll do in a different color, the negative 3. Negative 3 times x will be negative 3x. Negative 3 times negative 3 will be positive 9. Okay, and then negative 3 times that will be positive 3i. Now the last one I'll do in orange. I times x is going to be positive xi. And then I times negative 3 will be negative 3i. And then I times negative I will be negative I squared. Okay, so a couple of these things are going to cancel out. Do you guys see that? So the negative xi and this positive, so that's going to cancel out with that. This is going to cancel out with this. The 3x, did I do that right? I think it should have canceled. That's a negative 3x, and then that's a negative, no, okay, so that worked out. Alright, so I have x squared minus 6x, and then a 9, and that's going to be minus a negative 1, because I squared is negative 1, so that's going to be plus. That's going to be 10. Alright, so then to add this to the party, I'm going to have x squared minus 6x plus 10, like so. Now I got to multiply this, so this is going to be pretty. Alright, so x times each of these is just going to add another x. So I have x cubed minus 6x squared plus 10x. And then if I was to do the 2 times everything, that's going to be minus 2x squared, and then positive 12x, and then that'll be negative 20. So I'm just going to combine everything, and then I got my polynomial. So x cubed minus 8x squared plus 22x minus 20. Whew. There we go. Nice job. So the homework is just a worksheet. Okay, so we can have somebody pass around a worksheet for you if you want. Let me skip ahead to the homework. All right, that's the worksheet 3.4, 3.5. Good luck. I will see you guys next time, and I'm sure you'll have tons of awesome questions for me to answer. And hey, you could always just watch the video again. All right, see you guys later.